So in this case, we are going to move on to the cubic function, which is part of our algebraic graphs, all right? So basically on the cubic function, the highest exponent or that you're gonna remember use here is 3. The highest exponent is 3. Y is equal to x cubed. Y is equal to x cubed plus 2x squared plus 3x plus 1, something like that, all right, where the highest power that you are going to consider is what is 3. So given a cubic function, the format is given in the form y is equal to ax cubed plus bx squared plus cx plus d, like that. So here, that is where we are to keep in mind what we are dealing with. So once you see the format of this nature, that's a cubic function. So this a that we see here is for the shape. We saw it was used for the shape on a quadratic function. It is the same on a cubic function when a is greater than 0, because we actually expect a cubic function to be of this nature. All right, something like this. So when a is greater than 0, it is going to be going up like this. So that's for a is greater than 0. For a is less than 0 is the other way, like this. So that's facing down from this, where the graph has got two turning points. All right, it has got two turning points, minimum and maximum. All right, so all other aspects remains the same. All right, so the solutions where the graph is gonna intersect with the x-axis, the gradient, all those aspects as before, it's just the same. Only that on a cubic function, the solutions we're gonna expect to have what? 3 solutions, 1, 2, 3. Okay, so when it is maybe just passing through a single point like this, it means there's only one solution. It can be something like this. This one is a cubic function again, where it has got two solutions here, and this one being a solution, it is also a turning point. So we can have something like that where there are two solutions, but there are actually three solutions, because here you'll be referring here as two solutions, even though you write it as one, but there are two solutions which are at a single point. It is just like x is equal to -1, or x is equal to 2, or x is equal to 2. You have seen solutions like that. So the 2 and the 2 there repeat, that is repeating, is the one that is indicated like this, where there's a turning point. So it is actually 2 twice, or just x is equal to 2. So graphically, it'll be having a turning point and a solution at the same point, okay? So once you know the shape, the drawing part, table of values as before, you use your table of values. So like I said, guys, the quadratic opened a way, it was a paved way for all these other graphs. The same way that you dealt with a quadratic is the way that you're going to apply on a cubic function. So I'm not going to waste your time. Let us just try to sketch this one with the given scale, and going to have other questions later on. So just try to join the membership, all right, so that you do not miss any of the other classes that we are going to have revisions based on our O-level mathematics. So given this Cartesian plane, we are going to try to sketch the graph of y is equal to x cubed. All right, using 2 centimeters to represent 1 unit on the x-axis, 2 centimeters to represent 1 unit on the what? On the x-axis. On the x-axis for values of x ranging from -3 up to +3. All right, and 2 centimeters to represent, let us use 10 units. All right, 10 units on the what? On the y-axis. So that is what you're gonna need. So in this case, definitely you're going to use a table of values. You're gonna need a table that is insert the x values from -3 up to 3. All right, so that's x, y here from -3 up to what? Up to 3. All right. So in most cases, you'll be given all this and you just need to draw the graph or maybe find one or two of the missing values. So you're going to insert this when x is -3, y is equal to what? X cubed, -3 cubed, that's -27. All right, when x is -2 cubed, -8, -1 cubed, -1, 0, 1, 8, 27, like that. So you're going to insert those values, then we can see our minimum value is -27, maximum +27. For the y values, you must accommodate those values of which, all right, according to this one, we can win 2 centimeters to represent what? 1 unit on the x-axis from -1 up to 3, 1, 2, 3, -1, -2, -3. All right, 2 centimeters represent 10 units on the what? On the y-axis from -27 up to 37. So we're just gonna need up to negative what? Up to -30, where we can accommodate all values, and 10 up to 30 again, 10, 20, 30 like this. So this is our y-axis and this is our x-axis. All right, so that is it. Let us mark our points, and we can see that on the y-axis 10 boxes represent 10. So it means each box represent what? 1 unit, just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each box is a unit. Each box represents a unit. So let us mark our points. -3 -27, the first point that we are given, -3 -27, -3 -27 just before -30. All right, so that's -3. This is 30 -29 -28 -27 here somewhere there. So you mark a point on -3 -27, -2 -8 -8 just before, -10 -9 -8. So -2 -8. All right, -1 -1 -1 -1, just one box. Remember, one box, one unit. All right, 0 versus 0 here, right? That's 0 versus 0, 1 and 1. This is 1 and this is 1. One box going up. 2 versus 8 just before 10. Just before 10. This is 9. This is 8. So this is 2, 8. Then the last one is 3 versus 27. So 3 is here and 27 just before 30. 3 boxes before 30. So 29, 28, 27. So this is 3, 27. With these points, you are simply going to join them and you have your what? Your cubic graph, all right? You have got your cubic graph from there. Let me just try if this one is gonna work. Just trying, guys. Let's see. Where is it? Okay, why is it doing like this? Okay, guys. All right, this is not gonna work. What about this one? Okay, these things, no problem. Let me just use freehand. So just like before, you use your freehand, join the points smoothly. You must produce a curve. So here is just below the x-axis. Oh, here, below the x-axis. All right, then it reaches the 0. Below the x-axis, below the x-axis, going up to 1, going up. All right, let's go up. to this point, then up to the last point, smooth like that. All right. So this is the curve y is equal to x cubed. All right. As you can see here, there's just this as our single solution where x is equal to 0 when x cubed is equal to 0. So x is simply equal to what? To 0 from our graph here. So that's basically the shape. It can be the other way on the other side, but in most cases, you're going to have something like this where there are actually three solutions, something like this. So something of that nature. So just do revise as many questions you see. Then all those questions about area, you do the same, calculate number of boxes. If it is tangent at a certain point, if it is gradient at a certain point, you draw your tangent, do the same way as before, everything. All right, so let us just try to work out more questions based on the cubic function. And for the purpose of revision, where you do not understand, let's say working with a question paper, we can communicate so that we can work on those values. But that is it, guys. For now, that is what you're given. So let's do revise as much as we can.